All right, today we're going to work on solving a quadratic equation with the quadratic formula. So here we are given the quadratic formula when ax squared plus bx plus c equals 0. This is something that looks really complicated. I've heard people sing a song to memorize it. You'll be able to reference it as we go through this class. Remember that we're looking at something when uh, we got x squared plus 4x plus 6 equals 0. Okay. So here we're going to identify a value, b value, c value. If we need to, like if it doesn't equal 0, we have to move stuff over. Here, I just gave an example that equals 0. We'll get into this in a moment. A is 1, B is 4, and C is 6. And then we'll use that information to plug into our quadratic formula. It's one of those things where you usually use it when factoring by grouping doesn't work or completing the square. Quadratic formula is our last line of defense. Also, if you, no matter what, the quadratic formula will work. There's faster ways to do this. Um, but if you get to it on an assessment or if you get to a quadratic equation and you're like, I don't know, the quadratic formula will work, which is just a wonderful thing. Let's take a look at some examples here. I guess the best way, procedure first. So you're going to put the equation into the form ax squared plus bx plus c, and that equals 0. Make sure that it equals 0. You're definitely going to be facing problems that look like 2x squared minus 4x plus 22 equals 16. Something like that. Make sure that you have it equaling 0. It needs to match that. Substitute a, b, and c into the quadratic formula and simplify from there. So let's take a look at an example. Here, solve using the quadratic formula, 3x squared minus 3x equals 36. Looks like for some reason I've already included that first step. It's so nice. So we got to get that 36 into the negative there onto the other side so that it looks like our step 1 in our procedure, ax squared plus bx plus c equals 0. From there, I like to take a moment, identify our a, b, and c. A is 3, b is negative 3. Remember, we have to include the sign that's in front of it. That'll be super important as we go through. So a is 3, b is negative 3, and c is negative 36. And then we're going to use our quadratic formula here to solve for the variable. So let's replace all these things with our numeric values. Negative b. So negative b, negative 3 is positive 3, plus or minus the square root of b squared, negative 3 squared, minus, make sure that's in parentheses, minus 4 times 3 times negative 36, all over 2 times 3. And then from here, we just need to simplify. We always want to do our order of operations correctly, those kinds of things as we're going through. 3 plus or minus negative 3 squared. So let's keep the 3 plus or minus. We'll keep the square root here for a moment. Negative 3 squared is 9 minus, and then we'll see here. We need to do 4 times 3 times negative 36. We've got a negative times a positive times a negative. So this is actually going to be positive 432 over 2 times 3 is 6. Okay, I made the square root pretty long there, unnecessarily. Inside the square root, 9 plus 432 equals square root of 441. What is the square root of 441? I think that's a perfect square. It is 21. Okay, so we're going to end up with 3 plus or minus 21 over 6. Okay, 3 plus or minus 21 over 6. We can continue to simplify from there. Remember, we're going to have multiple solutions oftentimes with x, two solutions. So x equals 3 plus or minus 21 over 6. So we'll do 3 plus 21 over 6 and 3 minus 21 over 6. 3 plus 21 over 6 That'd be 24 over 6. 24 divided by 6 is 4. And 3 minus 21 is negative 18. Negative 18 divided by 6 is negative 3. So we've got x equals, and we've got our set of numbers, negative 3 and 4. So identified, put it into the correct form, identified our a, b, and c, plugged it in, and simplified. All right, let's look at another example. We've got 5x squared minus 13 equals 2x. This 2x, we need that to equal 0, so we got to subtract that from both sides, leaving us with 5x squared minus 2x minus 13. If we were to try factoring by grouping, we would do 5 times 13, and we're just like not sure. 65, how does that get to negative 2? So what we're going to do is just going to use the quadratic formula to solve this equation. A, B, C, A is 5, B is negative 2, and C is negative 13. Using my quadratic formula here, I'm going to start filling this in. Negative negative 2 is 2 plus or minus the square root of negative 2 squared minus 4 times 5 times negative 13 all over 2a, 2 times 5. All right, so let's start simplifying. We're going to keep the 2 plus or minus. Inside the square root, we're going to have negative 2 squared is 4. And then what we got here, 4 times 5 times 13. 20 times 13 is 260. Got a negative, positive, and negative, so I know that's going to be positive. All over 2 times 5 is 10. Plus 4 is 264 perfect square. It is not. So let's take a look at what we can do with that. So we've got 2 plus or minus the square root of 264 over 10. Remember, if we're going to simplify with our radicals, we got to think back to how we did that earlier in the year. And we're going to need to simplify that if we can. 264. All right, well, I know that 264 is divisible by 4. So when I went through that, I figured out, let's see, uh, 264, that can be split into root 4 and root 66. Square root of 4 is 2, so I'm going to be left with 2 plus or minus 2 root 66 over 10. Remember, the only way I can simplify is if all three terms can be simplified in this situation, because they are not like terms. This, I could do the even numbers, and I could be left with 1 plus or minus 1 root 66. That 1 is unnecessary, over 5. All the terms have to have something in common if I want to simplify a radical. Here there's two solutions because it's plus or minus. We have 1 plus root 66 over 5. I would accept this answer as well. 2 plus or minus 2 root 66 over 10. This is okay. I would like to see it more simplified than that. Awesome. Well, we'll be practicing this more. Just remember to go through your steps slowly and simplify as slowly as you can. It should be good to go for that. Let's see. Let's clear. Do I have another example? I don't remember. Nope, that's it. All right, we'll work on this more in